Question 9 of the worksheet on forces in motion. Two identical boxes, each of mass 400 kg, are at rest with one on top of the other on the horizontal ground. A horizontal force of magnitude P Newton is applied to the lower box. The coefficient of friction between the lower box and the ground is 0.75. So this value of mu would be equals to 0.75. And the coefficient of friction between the two boxes is 0.4. So between these two boxes, mu is 0.4. Okay. Show that the boxes will remain at rest if P is less than equals to 6,000. Okay. So if you remember from the lesson on friction, we've discussed that the maximum value of friction can take is given by this formula. Friction is equals to mu r. And if an object is supposed to move, then the force that is being applied on it must be bigger than this maximum friction mu r. So we'll find the value of mu r and we'll probably see that it is equals to 6,000. That is why if the value of P is less than 6,000, the object is not going to move. It will remain at rest. So we're going to find the friction at limiting equilibrium, which is this mu r. So, and they're saying show that the boxes will stay at rest. So we have to use the entire system. So that means we're going to use this mu that both the boxes exert on the ground. And for normal contact force, we're going to use the entire two boxes. Okay, so mu would be 0.75 and R is in this direction, which is opposite to the weight of the system. And weight of the system would be 400 plus 400, 800 times 10, 8,000. So this would be 8,000 R. R and weight are equal in this setup because the upward force is equals to the downward force. Okay, this gives friction equals to 6,000. So you write, hence, if P is less than equals to the maximum value the friction can take, object will stay at rest. Okay. The boxes start to move with an acceleration a meters per second. Let's clear this. Okay, now the boxes start to move with an acceleration of a meters per second square. Given that no sliding takes place between the boxes, show that acceleration is less than equals to 4 and reduce the maximum possible value of p. Okay, now if the object is moving, we will be using the formula forward force minus backward force is equals to ma. Okay, so let's look at the complete system. Forward force on this system is this. Backward force on the system would be the friction is equals to mass times acceleration. Okay. Now let's substitute the values. P, we don't know what that is. Minus mu on the entire system is 0.75. R of the entire system was the same, 8,000 is equals to mass is 800 and acceleration is what we have to show as well. So there's a problem in this equation. We don't know P and we don't know A either. So that means this equation cannot be used at the moment because we have two unknown values. They wanted the maximum value of P and they wanted us to show that acceleration is less than 4, less than equals to 4. So let's let go of this equation for now. And let's look at the upper block because they had also given us the mu for this. So there must be a reason for that. They gave us this mu, so we're going to look at the upper block as well. Now, although it says that no sliding takes place, that means the two blocks do not, detach. But If they detach, the movement is in this direction, right? So when you push this block towards the left, what happens that the upper block is moved towards the right. This moves in this direction. When you push this lower block, this block actually moves in this direction if sliding takes place. Let's look at the forces on the upper block. It's going to be, there's no forward force. It's going to be 0. And there's going to be friction. Friction is going to be in this direction, which is going to be equals to mu and r. Now its mu is different, 0.4, and its r is different, 400. So mu r will have this value. And there's no force being applied in this direction. This is going to be 0. Okay. Now we're going to use forward force minus backward force is equals to ma. Since the complete system is moving in this direction, so we're going to take this as the forward force. Forward minus backward is equals to ma. Mu is 0.4, r is 400, mass is also, r is 4000, not 400, and mass is 400 times a. This should give us 4. This gives us 4. Okay, we have to show that acceleration is actually less than and equals to 4. So I'm going to put less than and equals to symbols here. Less than and equals to, less than and equals to, like this. Now this is correct. And what is the logic behind is that friction is going to be greater than this MA since there's no sliding take place. So if the upper box is not to be moved, then the frictional value should be greater than MA. Only then sliding will not take place. Okay, now we have an extreme value of A, which is 4, which we're going to use here to get the highest possible value of P. So when A is 4, find the value of P. 800 into 4 plus 0.75 into 8,000 gives 9,200 newtons. So you had to look at the lower block plus the upper block simultaneously.